we were like really wrong. Because come to find out, these atoms have what's called subatomic particles, right? And these subatomic particles are little things that make up the little things that make up everything, okay? And then we thought that was it. So we started teaching kids that in school, okay? And then guess what? We were wrong again. There's even more stuff, okay? And that's what we're gonna learn about. There are things that make up things and the way that things are related all inside an atom, right? Which you can't even see. I think there's roughly like 100 atoms on a pinhead. So, yeah, we're talking that tiny, okay? Super tiny every time you hear the word quantum. Just think tiny. So, what is quantum physics? Quantum physics is the study of matter and energy, E-N-E-R-G-Y, at the most fundamental level. It aims to uncover the properties and behaviors of the very building blocks of nature. And also we should think bigger than nature. We should be thinking the universe, okay? And until further notice, the potential of more than one universe, right? While many quantum experiments examine very small, SMALL objects, such as electrons and photons, which are parts inside the atom that I was talking about, quantum phenomena are all around us, acting on every EVERY scale. However, we may not be able, ABLE, to detect them easily in larger objects. This may give the wrong impression that quantum phenomena are bizarre or otherworldly. In fact, quantum science closes gaps in our knowledge of physics to give us a more complete picture of our everyday lives. Okay? So there you go. That's what this lesson is about to be about. Okay? Let's go ahead and do some warm-up words. The first word I spelled for you was the word, actually let's skip that one. Let's do, how about we just do small, right? Let's start out small. You want to spell the word small, buddy? Go ahead, buddy. Small. S and M and A and up, buddy, to the right. There you go. L and back over. One more. L, small.
Nice.
Okay. Right on, man. Good warm up. Good warm up. Let's do a couple more though. All right. Let's do the word every. Okay. Acting on every scale from that sentence. Every. Go ahead. That was the first letter. E and V and E and up over to the right. Find it, buddy. Find that R. There you go. R and over to the right.
Find it.
There you go, buddy. Right there. Every. Y. Nice. Okay.
Nice.
Hey, good job shooting right back up to that E though. That second E. I saw your hand do that. Okay. Our last warm-up word before I ask you a couple questions is the word able. Okay? Able. We are able. Go ahead, buddy. Able. That's the first letter. A and to the right. To the right. There you go. B and L and E. Okay. Able.
Nice.
Okay. We're strong with our vowels. I noticed. We know where the vowels are on the keyboard. All right. So I think we're warmed up. Okay. You want to try a question? I was supposed to not ask questions. I forgot. Okay. And so quantum physics is the study of matter and blank. Okay? Matter and what else? Go ahead. What's the first letter? Find it. E and N and E and right next to it. Find it. Find that R. R and G and over to the right. There you go, buddy. Find it. Find that Y. Y. Energy.
Good.
That's spot on. Okay. Let me go ahead and keep reading the rest here. Good job, man. Okay. Quantum discoveries, so discoveries we've made on these small things, right, have been incorporated into our foundational understanding of materials, chemistry, biology, and astronomy, right? So quantum physics have things to do in all those sectors of the math and science department. These discoveries are a valuable resource for innovation, giving rise to devices such as lasers and transistors. And for the record, a transistor is just like, think of it as like an electric switch that can like amplify the amount of power that it allows to pass through. That's all it is. Don't get hung up on a transistor. And enabling real world progress on technologies once considered purely speculative, such as quantum computers, which are a real thing now. They're just really expensive because we have to keep them super cold. Okay? Physicists are exploring the potential of quantum science to transform our view of gravity and its connection to space and time. Quantum science may even reveal how everything in the universe, or as I was saying, or in multiple universes, is connected to everything else through higher dimensions that our senses cannot comprehend. Okay? So, out of that paragraph, I got 4 questions for you. Okay, buddy? So quantum discoveries have been incorporated into our fundamental understandings of materials, chemistry, biology, and blank. Okay? Go ahead, buddy. A and S and T and R and over to the right. Over to the right, buddy. There you go. O and N and back up, over to the right, over to the right. There you go, buddy. Find it. O and M and up and to the right. Find it, buddy. What's that last letter? Y. Astronomy.
Nice.
Yeah, man.
Guys
You're
are flowing.
right. Astronomy.
Good job.
Beautiful. Okay. Get that one out of the way. Sweet deal. All right. So discoveries in quantum physics has given rise to technologies such as those transistors and blank. Okay, buddy? What else besides the transistor thing? Go ahead. What's the first letter? You got it, buddy. There you go. Yep. L and A and S and eyes on the keyboard, buddy. There you go. E and R and S. Lasers.
Good.
Spot on, man. We're killing it. Okay. We did that one. We talked about transistors. Okay. This is from the same paragraph, okay? Once considered purely speculative, quantum blank have seen real progress. What is it that they're making? Right now they gotta keep them cold. What is it? C and over, up and over. There you go, to the right. O and M and up to the right, buddy. To the right. There you go. P and right, buddy, to the right. Up. U and there you go. T and E and up. There you go. R and S. Computers. Quantum
Nice.
computers. All right. I didn't know you were a scientist and a Rembrandt. Okay. The last question before I start reading. Scientists are using quantum physics to transform the way we see gravity's relation to space and blank. Okay? Go ahead. The first letter, buddy. T and up over to the right. There you go. I and up. M and E. Time.
Good.
Right on, man. Right on.
Spot on.
Joey, you were tearing this lesson up. You know I worked very hard on this lesson. Okay. Killing it, dude. Right on. Good stuff. I'll keep reading. Yep. The field of quantum physics arose in the late 1800s and early 1900s from a series of experimental observations of atoms that did not make intuitive sense in the context of classical physics. Right? So they were disobeying, it seemed, the laws of physics, which we'll get into as well. Among the basic discoveries was the realization that matter and energy can be thought of as discrete packets or quanta, that's what they call it, quanta, like a unit of energy or matter at the lowest level, that have a minimum value associated with them. For example, light of a fixed frequency will deliver energy in quanta called photons, P-H-O-T-O-N-S. Each photon at this frequency will have the same amount of energy, and this energy cannot be broken down into smaller units, right? Because this is the smaller unit. In fact, the word quantum in Latin has Latin roots and means how much. Quant, as in like quantity, right? Or in Spanish, when Julie talks, ¿cuántos años tienes? How many years do you have? That's what that means. It's a Latin-based language. Okay. So, my question for you, buddy. Light delivers energy in the form of what? Go ahead, buddy. What's that first letter, buddy? Oh, over to the right. There you go. Find that. Yep. P and find it. There you go. O and to the right, buddy. There you go. O and yep. T and back over to the right. O and yeah. Oh, you had it, buddy. To the right. There you go. N and right there, buddy. What's that last letter? Go ahead. S. Right on.
Nice.
Photons, right? That's a new one. I don't think you've typed up the word photons before, right?
Not that I know of.
Okay.
You might have though.
Photons. Check, right? Things that deliver energy. Or the way light delivers energy. Okay. Do you mind? I've got like 2 more to go. Do you want to get a check-in and see how he's doing?
Yes.
This is like around the time Dana would say, hey, let's get a check-in.
You have 2 more left?
Yeah, I got 2 more left, but it's kind of involving a lot of heavy reading.
Oh, okay.
Yeah.
Okay. We'll do a,
So it's up
I'll do
to
a
you.
quick check-in.
Okay,
Yeah.
I don't want to deprive him of his mid-lesson check-in, even though maybe-
Absolutely. Jojo, so we have 2 more questions, okay? You want to finish those, or what do you need right now? Any feedback would be good too. T, the, L, E, S, lesson is going very well. Great. Great prompting and choose to help my body reach the right letter. Right, Joe? Somebody anything to add, or we let's finish the last T W the last two.
Alright, sweet.
Alright, Joe. Do you need the bathroom before you finish? No. Okay.
Okay. Well, we'll still finish it. Or
Yep.
just I'll pause the video.